my high score is 31 million, and they have 174 million. I mean.
Hi guys,
So yeah, they're pretty fast, but
Roblox, and yeah. So yeah, I'm gonna be playing Roblox, and yeah, that's basically it. So let me just I'm gonna be playing Roblox, and yeah, that's basically it.
Wait,
so
wait,
that's basically it.
Bruh, she did. Wait. Roblox. I'm streaming. Wait, calculator. We need the calculator, bruh. Square root by 8 equals 2. Okay. Okay, I don't know how to do the sign. So then how to do the sign? So 1478 1470 square root. Let me see. That's not it. 8. 38. Square root. 38. Wait. Square root. Images. Yeah, that's it. What is the answer to 1478 square root? Wait. Google it. I haven't really done this, so imagine if she's watching, that would be the funniest thing ever. Bruh. That's not it, well. How to disclaimer? It's complete numbers. Oh my god, this new stuff. I don't really know. So, let me try an easy one. 1478 square root. Calculator. Let's see. 1478 square root or square root. Oh no, not the same. Square root. What's the answer? But that's the answer? But that's not. Wait. phone, let's see, calculator, Samsung calculator, let's see, some calculator, open, 1478, square root, no, not this thing, bruh, where's the square root, of something, where's this, 1478, bro, I didn't know, where's the square root, I didn't see the square root, like, what is it, oh there, fine, square, I never said multiplied, I think so. I mean, I think so, but I'm not quite sure. Square root, but it answer another format used, but square root. Square root. I mean, I think so. I mean, I think so. So I will write. I think so. I think. I think so. We haven't even, bruh. I can't even type. We haven't even done it. I think so. We haven't even done that. So, wait. What is? Wait. Easy one. 91 divided by 9. That is an easy one. I think so. Do no algebra. Wait. Algebra in math. Ding. Example. I'm not quite sure. Example. Square, scalar, and algebra in math. Dun. I don't know, but maybe, I don't know. Let me search up. Google. Let me see this. Algebra. Let's just type algebra. I mean, I know multiplication, but is that like letters? Is that like letters or something? Okay. No, I don't. Wait. What is this? Wait. I don't. No. Okay. Wait. What grade is that in? What grade is that in? Bruh. Depends. For example, Canada. For example, Canada. Some people learn it in US. And yes. And yours is probably like 5th graders. High school. Canada, yes. Bruh. Canada and US. Same. What grade do Canada learn it? Canada learn it? Or US? I don't know. I don't live in Canada. So US. It depends. Depends. LA. In LA. LA. It depends. LA. Is material. Oh. Then my Canada is like 9. Bruh, like seriously. Like, bruh. Like, bruh. Like 9. Let me do this. The Canada is like 9. Bruh. That sucks. Let me see something. Let's go to YouTube. Let's see to YouTube. How does algebra work in math? Algebra for beginners. That's exactly what we need.
Hello, welcome to the algebra course. What number needs to go there? So there's some mystery here. We're combining numbers together. In algebra, we have new things called variables or unknowns that we represent with letters. So for example, we have something like x plus 1 equals 5.
Wow.
We can think of x as just standing in the place for a number. What number needs to go there? So there's some mystery here. We're on the...
Wait. Oh. Yeah, I think I did algebra. So let our mystery number. So let our mystery number. Okay, and yeah, I did that.
Hunt for the number that goes in place of x? Well, this example is not too hard. If instead of x, if we had in place of x there in that equation, if we had 4, then 4 plus 1 equals 5. That's certainly true. So instead of that x, we need to put a 4. So what we say is that x must be equal to 4. And there we go. We've solved our first algebraic equation. We started with an unknown.
Like, I don't remember, maybe grade 3. Maybe I did. Maybe I didn't. Maybe I didn't do it. But I know how to. Now I saw what it is. Okay, whatever, let's keep watching.
But it doesn't have to be x. And in fact, let's see another example of an equation with a variable. So how about a plus 10 equals 12?
How to do plus and then English keyword. Is plus, wait, English keyboard. English keyboard. Let's see this. Where's the plus? The plus is right there. So now we know where the plus is. So that's not it. So where's the plus there? For example, like x plus, x plus 5 equals 7. I think that is what is.
So what has to go in for a? Now when we move to if we want to include all the fractions, then we move to the rational numbers. So for instance, 1/2 is a rational number, but it's not an integer. Now 1/2 is a rational number because if you look, 1 is an integer in the top and 2 is an integer in the bottom. So when we make a fraction with integers, that's a rational number. Now can you think of any examples of a number that is both a rational number and an integer? Well, 5 is both.
Equals 7.
Why?
Wait, I wanted to make another line.
5 is definitely an integer and a natural number for that matter.
Not.
But it's also a fraction because 5 is the same thing as 5 over 1.
X
Now 5 is an integer and 1 is an integer, so we can write 5 as a fraction of integers. So 5 is a rational number and an integer. In fact, all the integers are rational numbers. Now what about things that are not rational numbers? Well, the square root of 2 is not a rational number, but it is something called a real number. So real numbers are all the rational numbers, all the fractions, and there's these mysterious things like the square root of 2 and the square root of 3, and
Equals.
numbers that we call irrational.
Equals.
So, for example, 5 halves is a fraction, so it's both a real number and a rational number. But the square root of 2 is only a real number. We'll talk more about the real numbers at the end of the video, but they're really, really, really important. They're the numbers we'll be using most often in this course. Finally, we get to the complex numbers, which are just real numbers with imaginary numbers, things of the form a plus bi, where a and b are real and I is the imaginary number square root of -1. Now, if the complex numbers right now seem mysterious and weird to you, don't worry about it. We'll talk about it later. But let's revisit the real number line, or the real numbers. So this is the real number line, and it's just a continuous line of numbers. You can see we have all the integers, 1, 2, 3, and so on. We also have everything in between. So for example, right where that green dot is, that's perhaps the square root of 2, because the square root of 2 is approximately 1.414, and it keeps going on forever. So it's just a little less than 1.5. Now, the interesting thing about this is that if we were to draw a number line with only rational numbers, so only fractions, well, we already talked about the fact that the square root of 2 is not a rational number. It's not a fraction. So if we drew a number line with only fractions, there would be holes in it. There would be a hole where the square root of 2 goes. So the real number line is really special. It has this property that every number is there. There's no holes or jumps or gaps. And we'll use the real number line in that sense, that basically when we can think of it as all the numbers on that line, the whole line is continuous and filled with numbers. Okay, see you in the next video. In the last video, we learned how addition and multiplication have this nice property called the commutative property. Now we're going to learn a new property that addition and multiplication both have, and it's the associative property. So addition is associative. Let's start with addition here. So A plus B as a group plus C is the same thing as A plus the group B.
Minuto.
B plus C. So really it tells us something about how we're grouping addition, where we write these parentheses. And really it's saying it doesn't matter where we write them because they're the same. So let's see an example. 9 plus 3 plus 5. And we'll do 9 plus 3 as a group. Well, this is equal to 9 plus the group 5 plus 3, or 3 plus 5. So 9 plus 3 is 12 plus 5, and then on the other side we're going to get 9 plus 8. 12 plus 5 is 17, 9 plus 8 is 17, and so we can see the associative property in action. Doesn't matter where we put the parentheses.
So 8, right?
Both sides are equal. Since it doesn't matter where we put the parentheses, what we're going to do is just drop them. The parentheses don't tell us anything interesting, so we don't need them. It doesn't matter where we put them, so why put them anywhere? Okay, so that was addition. Multiplication is the same. Multiplication is associative.
Too much school? Папа, у тебя кофе.
Макрон и Шольц закликали Зеленского.
Есть идея. Минута. Готово.
Hello, welcome to the algebra course. My name is Mike and I will be teaching you this course. So what is algebra? Well, loosely translated from its Arabic roots, algebra means balancing and restoring. But that's a little bit boring, and to us, what does that mean so far? Well, it means nothing really. I prefer to think of algebra, like all math, as the mystery of the unknown. And what do I mean by that? Well, before you get to algebra, you do things like adding numbers, subtracting numbers, multiplying, dividing numbers. And there's really no mystery there. You're just kind of doing arithmetic. You're combining numbers together. In algebra, we have new things called variables or unknowns that we represent with letters. So for example, we have something like x plus 1 equals 5. We can think of x as just standing in the place for a number. What number needs to go there? So there's some mystery here. We're on the hunt for the number that goes in place of x. Well, this example is not too hard. If instead of x, if we had in place of x there in that equation, if we had 4, then 4 plus 1 equals 5. That's certainly true. So instead of that x, we need to put a 4. So what we say is that x must be equal to 4. And there we go. We've solved our first algebraic equation. We started with an unknown called a variable x, and we found out it had to be 4. So the key idea here is that x is what's called a variable or an unknown. They're synonymous. And what do we need to know about variables? Well, variables just stand in the place of a number. In our example, the letter x, the variable, stood in place of 4. Also, variables are usually written as letters.
Wait, wait. No, right.
Okay, algebra.
Algebra for beginners. Let me save that. But